I'm Dr. John Estes, and this is What are Differential Equations? And we are going to talk about what a differential equation is and ways to classify them. Alright, so what is a differential equation? It's not as confusing as you might think. It's simply an equation that relates a function to one or more of its derivatives. So as an example of this, all we need is to take some function. Typically we'll call that function y, though it doesn't have to be y. That's just what we standardly use. And we'll relate that to one or more of its derivatives. So for example, we could say y double prime equals x cosine y minus x plus 1 y prime. And this is an example of a differential equation. Now, your strategy to solving differential equations depends on what type of differential equation you have. So next, we'll look at ways of classifying different kinds of differential equations. Now we'll talk about the classifications of differential equations. And again, determining what type of equation you're dealing with will help you determine what method you need to solve it. So we'll look at some of the three major ways of classifying differential equations. The first one being, are you dealing with an ordinary DE? These are often called ODEs. Or are you dealing with a partial differential equation called PDEs? And I can do an example of both of these. So for an ordinary differential equation, well, you're not dealing with partial derivatives. So you could say something like y double prime minus sine x y prime equals 0. As an example of a partial differential equation, maybe you could have dx dy minus dz dy equals some sort of constant. And that would be a partial differential equation. Now, for most, if you're taking the first semester of differential equations, you'll be dealing mostly with ODEs, not really much with partial DEs. The second way to classify a differential equation is by its order. So let me do some examples of this, and let's see if we can figure out what we mean by that. So here's an example. Of a first order differential equation. Here's an example of a second order. And hopefully by now the pattern is obvious. If we have an nth derivative plus some things equal to 0 or some constant, then you have an nth order differential equation. So higher order will require different methods of solution than lower order, and particularly first order. Lastly, the third way to classify DEs that we will talk about is by linearity. And again, I'll highlight this with an example. Say x plus 1 y triple prime minus tangent x, I like those trig functions, y double prime, minus 3x y prime plus 5y equals 0. So this is a third order differential equation, but this equation is also linear. Let me give you an example of one that's not linear, and let's see if we can figure out why. Let's say y prime times the square root of y minus 1 plus cosine of y double prime equals 0. I say this top one here is linear, and the reason it is because And notice all the y terms are not either being multiplied together or they're not trapped inside functions. Whereas in the second example, this one is not linear. And the reason being, here I have a square root of y minus 1 times a derivative. That's violating two laws. We can't multiply y terms, and we can't put y's inside a function. And same here, we can't have a cosine y. These are examples of things that make these equations nonlinear. So if you have a linear equation, it determines a way to solve it. If it's not linear, you need to look towards something else. So I hope this video has been helpful. I will try to make more of these to help show you how to solve differential equations based on these different types.